continue. Why we call requirement-driven agile? It sounds like requirement-driven means requirement completes the requirement first, but actually it's not. Requirement-driven means a spec need to exist, and a spec need to remain exist instead of burn out into working software, and a spec need to be driving not only the development but the testing. But it does not mean an abstract will contains all the requirement detail. The requirement detail, as I explained, requirement space, if we use a tree to represent requirement, then the spec and the epic only represent the skeleton of the tree, the branch, the stem. The documents represent the life, the fullness of the requirement space. They can be added. They will grow at a later time. In other words, you're going to have development task representing a commitment of a requirement. But the requirement task can be done or during the process of finish the sprint. Most of the time, a requirement needs to be fully specified. Sometimes the requirement won't be fully specified because we're going to close the story. We know this story is done, but the requirement spec 1 is not done at all. We're going to improve the requirement. We're going to create more stories at a later time, like the story 3. Sorry, there is story 1-3. And we're creating a feature story 1-3, but to implement the improve or the modify the requirement spec. So let's define the story in more details so that if you in the future refer to this training material, it's easier for you to get your thoughts all together to understand what is a story versus what is a spec. A story is an implementation of a spec. It can be used to drive implementation. Obviously, story exists mainly to drive a requirement spec 1 to become the working software function. And it can become a working software function because you create development tasks. After all, you need a developer 1, or you might create multiple development tasks to do the implementation to make this story 1-1 to become working software function. So it's used to drive implementation, but it's also used to drive the understanding of a requirement or the improvement of a requirement. Without the working software, so often the requirement will not be complete. And without creating the task and creating the subtask of a QA testing event, you actually might not be able to drive the creation and the refining improvement of a testing case, test standard. Or let me say the other way, you might not be able to effectively and easily and repeatably to conduct work for defining the testing. So a story for feature versus story for defect fixing could be different. So a story for feature represents, of course, a commitment of a requirement that needs to be implemented. But what if you create a story for defect? We have seen many customers like the idea of let's creating a story to serve as the parent of group of related tasks. And it's so good so that even defect, they use the story to represent a fact. I need to do a defect fixing, but in order to fix the defect, I might need to have multiple tasks to be assigned to the programmer or the user interface designer to drive the defect fixing. To some extreme, sometimes you might create a standalone story with no requirement linked. It's merely serving the purpose of, now I can freely create a story to represent the fact I want to fix the defect, but I really need to group several tasks together for such purpose. So a standalone story which has no requirement linked, really serving the purpose, can be used to serve the purpose. It's a parent of a set of grouped tasks, whether for defect fixing or whether to represent in a very free way of doing several tasks development but together as a story. And then, of course, why do you want to do that? You should always create. It's a better practice is to create a spec with the exception of defect fix, of course. Even defect fix, it will be better for you to create a story and link with a functional spec that represents the origin of the defect. But it's created for flexibility. Okay, so now we're going to talk about the sprint backlog and the workload. So a sprint backlog consists of a list of story and a task assigned from requirement space or product backlog. The workload percentage does not include the QA child task. QA test child task represents the testing effort. It represents two types of work, test and verify. The parent development tasks are done with quality and creating and improving test cases. QA testing is part of all tasks, but no time remaining estimate is needed. So, in other words, if you see a sprint number 1, if you see the workload of the entire sprint, then it might tell you for the entire sprint we have total of 31 tasks and a total of maybe 10 stories. And together, you know, we know how heavily the team is loaded. But if we look at each team member, you see sometimes the story, sometimes the task. The two icons represent both the task and the parent stories. So obviously, sometimes you're going to see a standalone task like 58, which represent a defect fix, or which represent just a standalone task with no requirement linked. Same is true for tasks number 55. As each of the tasks, they have time remaining, like 5 hours, 5 hours, so you know everybody's the workload. But for the QA testing child task, we claim there's no need for you to estimate the time remaining. So if you do not practice estimating the time remaining for QA testing child task, it's good, it's also bad. Let's say why it's bad for us. It's bad as a result, you do not know the complete workload of the team. But why do you need to know the complete workload? So that's bad. So it's good because it greatly simplifies the way for you to estimate the time remaining, for you to accurately predict what is the total workload of my programmers, my drivers, who are driving to create the working software from those committed requirements and committed defects. We are saying make the time estimating for such driving to be accurate, but sacrifice the time remaining needed for QA testing the child task. The reason is the following. For QA testing, you need to do testing. For each of the testing, you do amount of testing so that it's good enough for you to claim, I verify the quality. of the development task. For development task, it's different. We want to accurately estimate the time remaining. So as a programmer, I say, I'm going to spend 2 more days to finish this task of, no, actually, I'm going to spend just 5 hours more to finish this task 58. I hope it's going to be true. And we trust you're going to be driving yourself to finish such claim on time. For QA testing, there's no such need. Every single development task needs to be tested. We do not really care too much about what's your estimate for you to testing. And it's almost impossible anyway at the day 1 to estimate all the QA testing effort. And it's absolutely possible, it's absolutely needed to test it all, to estimate all the time remaining for the driving effort, for the implementation for the programmers and for other owners who are creating the working software. And QA testing, we view them as protecting the quality, not necessarily is the driving force of creating the working software. Instead, it's the force of protecting the software from being created to be too poorly, with poor quality. So how do you measure the productivity of a development sprint? It's actually related to what we just described. You want to measure the development sprint productivity more based on the development task, not necessarily based on the QA testing subtask. So we can measure by using burn down chart, by checking the completed number of tasks or completed points, which is the velocity report, or total testing effort and number of testing failed. That can be also judging the quality of the productivity, which is related, the quality of development work. So it can be best accomplished, or such measuring of productivity is really used for creating a balance between the self-driving and team management practice. So what's the difference between number of tasks finished versus points, velocity? As we say, a task has a size. A point is used to represent how big is this task. What's the contribution of task 1? It can be 10 points versus task 2. It's only 1 point. So just measuring the completed number of tasks is not enough for productivity. You need to measure the points finished. So here is a burn down chart. It shows you the completed number of tasks. Easily, this completed number of tasks can be converted to show you the completed number of points, right? It shows you the time remaining burn down. It shows you a line. Ideally, that's the way you finish the work. So obviously, you want to see your team estimating the time remaining on a daily basis. Since the time remaining estimated is done by each team member, regardless of the skill level, as a newly joined team member estimating to finish a task that requires 5 days, actually it's going to take a skilled programmer only 1 day. But nevertheless, this 5-day remaining is more accurate because that is the reality of a newly joined programmer, of how much time it's going to take for her or for him to finish. So the time remaining, when practiced right by each team member, it's going to show the true progression of the tasks that are being done effort by effort, hours by hours, days by day, by each of the team members. So it can predict if we're going to be on target, finish the sprint or not. The number of tasks finished without the time remaining is not going to be as predictable for the future of whether the team can finish the task or not. And same is true for points. Velocity report across sprint is another measurement. As I explained, points represent the size of a task. It's often represented sometimes with no physical meaning, sometimes with physical meaning by team. No meaning, we just use a Fibonacci numbers to represent the size of every single task. So as a result, you cannot really use the points report to compare the productivity between team 1 and team 2 because the standard is different. Another way is to use the point to represent the size of a task, representing an average skilled person of your team, not the best, not the worst, but in the middle, taking the ideal time, meaning the focus time without playing games, browsing internet, doing nothing but consuming the time. That's the average time, the ideal time of average skilled person. That's the point. So as a result, you can indeed measure the productivity of the same team across multiple sprints. So we're going to do a training poll again. Question number 3. What activities below will increase the time remaining related to current sprint tasks? More QA test cases needed for a spec with current sprint active stories. A test child task failed. The task owner needs to re-implement a wrongly finished task. QA floater yet to verify all test child tasks. QA regression testing cycle just started with story being tested, meaning the regression testing cycle started. Now we're going to test a lot of the current sprint. So what do you think will increase? This is kind of a tricky too, actually.
Okay, we'll leave the polls open for 20 more seconds. Well, it seems to be an overwhelmingly strong answer. I'm going to close them and post the results.
Okay, so 5, 15, 70, 0, and 5%. Okay. Yes, if you need more QA test cases needed for the related spec, but as long as you're not creating more child testing tasks, it's not going to increase the time remaining. QA test child test failed, then it will trigger often to increase the time remaining. Meaning, as you work on a task, the QA floater create a child task and give you a test case and remind you, please verify this test case. Sometimes you as a owner of the task perform the testing yourself. Sometimes QA floater will do the testing for you. But whenever the child test failed, time remaining cannot be 0. It should increase. In Dev Suite, we actually implemented an automation rule. Whenever a test child task failed, the time remaining minimum, it needs to be set to be, say, 1 hour, 2 hours. So there's no way you can claim this development task is 100% done because there's a time remaining value there. Obviously, choice 3 is correct. Task owner needs to re-implement the task for whatever reasons. And the QA floater yet to verify all tests, child task well, it's not directly increase the time remaining, but potentially when the task proved to be wrong, testing failed, it's going to increase the time remaining. The period regression testing cycle just started. I'm glad, most of you believe this is not going to increase the time remaining of a committed task. I'm just very glad for this, because naturally we would like to think, regression testing will help us to make the current sprint to have higher quality. It's so naturally, so easy to think that way. But let's honor ourselves. Agile, one of the success reasons Agile being successful is to create a self-driving team. A self-driving team need to have a sense of feeling ownership. They can commit all the tasks on day one, estimate all the time remaining needed, feeling comfortable we are going to finish all the commitment. So don't add additional defects. The regression testing should create additional defects, but assign to the product backlog for team to pick them up in the future sprint, not the current sprint. So time remaining will not be increased at all. Let's do, I believe, one more. Is this one more or that's it, I think? Let me see.
That's it for right now.
Okay, great. So this, we're going to spend 20 minutes of time on this discussions and the presentations. So we're going to spend like 10 minutes and then 5 minutes of presentations. I want you guys to create a sample requirement space and the development space and create 2 sprints and populate the sprints with story and task and use them to describe a sprint process. To some degrees, I don't really care much about how well you can present the sprint process, but I hopefully can see some pictures or some Word document, Excel, or anything so that you are comfortable. There is a requirement space. There are epics. They are broken down into specs, and the specs are estimated. And then you can create the backlog stories, or you can assign them directly from the requirement spec to sprint. Somehow illustrate them, showing the dynamic nature of such development sprint. At the development sprint level, somehow you can even connect. This is the way my development task has the time remaining. It's going down, and then it becomes 0. And so when you describe it, you do not need to draw the burn down report, but enough skeleton, enough picture illustration, so you can present nicely. This is the way the task gets assigned, time remaining estimate, and goes down. That will be great. And I want to remind you, ideally, the same presentation will be used at a later time by the second presentation time to fit in the quality practice into this, the same pictures